This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Get Push. Ship It is brought to you by Fly.io, the home of changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Okay, friends, I'm here with a good friend of mine, Shane Harder, the founder of Chronitor. Check them out at chronitor.io. Chronitor lets you keep tabs on your cron jobs, Linux, Kubernetes, Apache, Airflow, Sidekick, and more. With over 12 open source integrations, you can instrument all your jobs no matter where you're running them. So, Shane, one of the things I love most about Chronitor, I'm a user, as you know, is how great the UI is. It's very nice looking, it's easy to use, I can easily see all my jobs, it's easy to see all the details of my jobs, the timeline, the status, success rate, executions, and any alerts that I should pay attention to. How did you get to this user interface for Chronitor?
It's something we've been working on for years to get right, and it comes down to three key experiences in the app. And the first is just the overview of all your jobs and like what they're currently doing, what their recent execution history has been, and like what their overall state is. And then you can see that also on a timeline view. You know, like Chronitor was like the first one to do this, where instead of just having to look on a graph or a list, you know, jobs run on a timeline. You just put them on a timeline. So you can scroll back in time and see what happened like yesterday. You can also scroll forward in time and see like what your upcoming scheduled jobs are. And then when you drill down into like a single job, like what you're able to see in there is all the details that you need to understand what's going on and debug any issues that might be happening. So you've got the normal performance graphs and success rate graphs, and you can drill into stack traces and the complete log output from any job execution. What makes these screens glanceable still is really disciplined use of color, where the whole app is in really sort of pleasant neutral tones, and we only let ourselves use like bold color on the areas where we really want to focus your attention. So if you see red or green on the UI, it's there intentionally and purposefully. And usually if you hit a screen, that's the first place your eye is going to go anyway. And we wanted to highlight that and make it easy to find and let you explore the rest of it and uncover the rest of it from there.
Okay, friends, join more than 50,000 developers using Chronitor. I'm one of them. You can start for free, and they have a pay-as-you-grow pricing plan. Setup is too easy with more than 20 SDKs. Check them out at chronitor.io. That's chronitor.io. Again, chronitor.io.
Hello and welcome to Ship It, the podcast all about what happens after you get push. My name is Justin Garrison and I'm your host, and with me as always is Autumn Nash. How's it going, Autumn?
Good. This was a good interview.
This is fun. It was not at all where I kind of expected the conversation to go, but I had a lot of fun with it.
I thought so too.
Had you ever heard of System Initiative before?
I hadn't. I spent some time listening to Adam's interview because I really like the Friends interviews, because I always think they're really interesting, and his life was wild. Like just his whole, like how he got here and the different things, and who would have thought that like cartels and ISPs could be related, and like, so I thought that like I was really excited to like see what he came up with next, because it just seemed like he had so many cool, like, hey, I was really into this and I ended up doing this. And, like what a way to have a career just built off of like.
Well, and people that think that there's like a single path for any career. It's like,
I think that's like the most toxic part about engineering is everyone's like, and you have to have this background and then do leak code and like, and I'm like, all the coolest people I've met in technology have the craziest like a roundabout way of getting here,
Yeah. I also like that you brought up the cartels and ISPs because that ties into my outro. And so we'll have fun talking about
Wow,
that
Justin.
too.
Wow.
I'm just teasing it.
It's
and
always
like,
a roller coaster with you.
So today on the show, we have John Watson and Scott Prutton from System Initiative. They're both infrastructure engineers. And System Initiative is a new idea and way of managing infrastructure, which I had played with last year in their like early betas. I literally have their, where was it? Oh, I have their, oh man, I put it away. I have coasters from they called it Team 1 or something like that. It was like people that beta tested it. And so I was beta testing it last year. So I knew a little bit about it and knew it was eventually going to be a hosted service, but they've come a long way as any startup product does in a year. And so I was really excited to jump into this with John and Scott.
That's really cool.
Yeah. So let's go ahead and just go right into the interview, and then we're going to come back and talk about a couple different topics, some long reads, as I'm going to label this one. So. Thank you so much, John Watson and Scott Prutton, for coming on the show today to talk about what you're doing with System Initiative and some things that I found really fascinating about how you are building it and how you're hosting it.
Thanks for having us.
Thank you.
Can you just start by what infrastructure or applications or software are you responsible for?
So John and I are both responsible for running the like SaaS operations of System Initiative. So like broadly speaking, it's a pretty traditional app. You know, we have some services, they talk to a database, they communicate to each other over NATs. And we're responsible for making sure all of that and all of the supporting infrastructure is up and running. So, you know, load balancers, databases, multiple environments, all the build and CI/CD stuff, kind of the whole thing. We do it all. So, yeah.
I know if people are listening to other changelog shows, Adam's been on a couple times recently on various shows. Can you describe System Initiative for people as like, we know the rough architecture of how it puts together, but what does it do? What's it for?
Yeah, you know, there's a slide that Adam reads out to us every week that has a really succinct 30-second elevator pitch that I don't have memorized. So I'm gonna butcher that. But I like to think of it as like a hands-on way to design and build your infrastructure. So like I worked as a cloud architect for years, and most of my job was like drawing diagrams and showing them to people and then building what was in the diagram. And I like to think this removes some of those steps. And it basically is the diagram is your infrastructure, and whatever's in the diagram like is a real thing somewhere in the cloud that you've built and you're hosting. So it's that kind of tool. How do you feel, Jen?
I think it's like, yeah, pretty much what Scott said. It's like there are a lot of tools out there that let you kind of like create an architecture diagram, right? But none of them actually let you interact with the architecture. They're separate, right? So you would maybe use Terraform to make infrastructure changes, but then reference a static infrastructure or architecture diagram that you have to update frequently and things like that. So System Initiative basically pulls those both together. So you can interact directly with the infrastructure, create VPCs, restart EC2 nodes, run SSM documents against different autoscaling groups, various other things directly against the diagram, which is pretty cool.
Yeah.
And a lot of that assumes that I guess you have those APIs to do that automation, right? Like this is how would I do System Initiative for on-prem?
I mean, effectively, everything we do is a function running on a graph. So, you know, if it has an API, we can integrate with it in some meaningful way. So like, you know, if you think about the diagram and it's a bunch of boxes with arrows pointing to each other, let's say the box is an EC2 instance. Under the covers, there's functions that we run that integrate with the AWS API and say, create EC2 instance, delete, you know, et cetera. So, you know, depending on what you're using on-prem, if there's some available API that we can talk to, you can build components and assets and basically like design the whole thing to work and run whatever functions it needs to run to like create and have the infrastructure be managed. So like it's not just AWS that we're managing. Like you can interact with Docker images. I know that John's been starting to like tinker with like Google Cloud. There's some other like small integrations that we've built. I built some stuff with GitHub. So like if it has an API, if you can interact with it programmatically, we can make it happen.
Where does that order end for like, hey, I'm going to create an EC2 instance and then I want to SSH in and run a command, right? Like at some point, like you could do that a variety of different ways. And there are, I guess, API-ish things that kind of expose that. But where do you see system initiatives stopping?
I know that Adam has like a lot of opinions about this. We've talked about this like specific thing in particular of like he would love it where you could click on an EC2 instance and we could just open a shell like right to it. And that is totally possible because AWS has tools for that kind of thing. I think where we've been focusing and how John and I have used it is primarily around like designing your infrastructure and deploying it. And like we actively manage the SaaS instance of System Initiative using another instance of System Initiative. So like it's out there and this is how we do our like day-to-day work inside of it. And that's kind of where our focus has been. But what the tool can do today is I think very different than where it might end up in a year or two. There's a lot of opportunity there.
One thing that we haven't really talked about is like the tool is basically like an authoring tool and an architecturing tool. There's two very separate concerns within the application that are both key cornerstones to the value proposition. So not to turn this into a sales pitch or anything, but basically, as Scott was saying, you can author support for basically anything that has an API, right? And what that lets you do is imagine against the EC2 assets or the EC2 kind of component, you can add your own custom functions. So imagine you ran a Java app on an EC2 node, for example, or an autoscaling group. You could write your own custom business function or private function, whatever you want to do, to say like, log on and delete this dodgy file that says the health check's passing. You know, that's how everyone knows there's dodgy files, right? So whatever your business function is, it will let you do it. You author the function and it will go on and you can run that as like a runbook. So one of the ways that I've been using it is like, I wrote a function for us internally that runs an SSM document against all the EC2 nodes in a particular group or function and hits USR2 code against the binaries that are running, and it will bump the log level, and that's how our internal applications will respond. So, you know, if you're running your application differently, or you can write something that interacts with them.
How did you guys end up at the startup, and what'd you do beforehand?
My story is genuinely true. I was working for another startup in Manchester, and someone in the internal infrastructure engineering chat posted the job and said, look at this ridiculous out there reach for the stars kind of thing that none of us can kind of get. And I was like, hang on a minute. And I applied for it and got it. And that's genuinely true how I got the role and how I heard about System Initiative in the first place.
You know, I feel like you are so much fun between the fact that you got a mustache as a joke for a picture and the fact that you have to, and then that job story to be so much fun to work with. That's awesome. What about you, Scott?
I worked at another startup as well, and it was a database company. And it was weird because like, I don't know, I feel like I didn't really know or care that much about databases, but I worked at a database company, so it wasn't a great fit. But I knew somebody on the inside here that convinced me to apply for the same job as John. And when I interviewed with Adam, I told him to his face that I didn't think what he was doing was like actually going to solve the problem. I was like, I think you like described the right problem, but I don't think this solution is really the right solution, but I'm willing to give it a shot. And he was cool enough about me telling him he was wrong that I was like, maybe I want to work with these people. And everyone else that I interviewed with was like, it was almost more like, I'm really like, I want to see what we can do because this seems like a really solid group of people and like a cool idea. I'm bought in now, but you know, I was like a detractor when they hired me.
I think that's almost good though, like having different varieties of opinions in a room and people that are willing to listen and people that are willing to question you and to like want your product to be better. Like it's not, maybe if you didn't like completely didn't agree with the idea overall, but like that's how you make things better when someone's not going to just like kind of yes man you. You know what I mean?
Yeah, for sure. Like disagree and commit, right?
Yeah.
You know, we everyone get a chance to say your opinions, pick the path and go down the path for sure.
Wait, did you work on Amazon before?
No.
You said
I've read some stuff.
Like,
yeah.
I'm sorry. I have PTSD from disagree and commit for RTO, and I
worked as like a manager for a while, so I picked up a lot of like fun buzzword sayings that I can throw around when I want to,
So at this point, you're both there, and you've bought into this idea of what System Initiative can do for infrastructure management so much that you're hosting your SaaS with it. You said you had another version or another copy of System Initiative that is hosting System Initiative. So it's kind of self-hosted in that way, right?
Mm-hmm. Yep.
You kind of said the basics of it. It was EC2 instances with NATs in a database, right?
Mm-hmm.
How does that work when you're doing that for a SaaS? Like, is it a multi-tenant application? Are you running multiple versions per customer? I guess it's coming out, right? So it's like, you're getting there.
Yeah, we're getting there. It is multi-tenant. There are some versions of, some version of the future where we might run, I won't say like a instance per customer unless somebody really, really wants that, but maybe some like hybrid, they host part of it in their cloud. Most of the infrastructure is very standard, but we have like our engine that runs the functions that anybody can write. We use Firecracker to like spit out VMs and run like isolated code. So that part's a little unique, but yeah, it's pretty standard otherwise.
You're managing Firecracker yourself on EC2, not doing it through Lambda?
Yeah, exactly. So we built this whole thing. We call it Veritech. Adam and friends are, whoever builds a service gets to name it.
That's awesome.
Yeah. So I can't remember now what Veritech is from, but it's from like an old
anime. Like a robot or something, right?
Oh, Robotech, I think.
Yeah.
Is that it?
Yeah,
so we have a thing called Veritech. It creates cyclones. Cyclones are basically a little server that runs inside of a Firecracker VM that runs the untrusted code and then returns the response back to Veritech. So John and I built like VM instance that we spin up on demand. We have a whole pool of them listening, waiting for work, and they're single use. So you send code to it, it runs the code, and then it tears itself down. So we can run like thousands of these pretty like a second, more or less, to get a lot more throughput. Like it is what Lambda uses under the covers, but we have a lot more control over it. We don't have to worry about timeouts and cold starts and those kinds of things. Yeah, it's pretty cool.
What's it like going from solutions architect to infrastructure engineer? Because you're the first person I've ever met that has the same background as me. And I think people side-eye like solutions architects and think that they're not super technical, which is a total lie. But yeah.
Yeah. I've done everything. I started in QA and I was a manager and like I was an enterprise architect and like a software architect and a cloud architect. And I was a manager at my last job for like a month. And then the team I was hired to manage was like disbanded. And then they're like, you're an engineer now. And I was like, I guess I'm an engineer now. And I rediscovered my love for building things there. And it was like, this is what I really want to be doing. So I don't know. I fell into not engineering roles just by like inertia and being the loudest voice in the wrong place, I think. So yeah, I don't know. I feel like I have the chops. And I'm not afraid to use them.
It's good that you're good at disagree and commit. I think that's like an important skill.
Yeah, for sure.
What's up, friends? I'm here with Kyle Carberry, CTO at Coder.com. So Kyle, I've known Coder as the IDE in the cloud, and over time, you've iterated to become a fully open source cloud development environment, a CDE. How do you explain what Coder is and what it does?
Coder is a platform to provision you a development environment on any cloud infrastructure. That might be in a VM, that might be inside of a container, but Coder is kind of a developer's route to provision infrastructure for them to write software inside of. We started with the IDE, which is kind of like putting VS Code in the browser, which is what most people are certainly familiar with us for. And we kind of funneled that into more of a platform where people provision the infrastructure. And a lot of people do use a web IDE with Coder. A lot of people use a local IDE and just connect in.
Okay, so what are teams coming to you for? Who's coming to you?
What people really come to us for, particularly this problem is really exacerbated if you're a large enterprise, is when you have like 500 engineers that are trying to update like a version of Python. And instead, we allow one engineer to go through that tedious work of updating some scripts or some Docker container. And then you can actually just deploy that in one click to say like 500 engineers and make it really, really simple.
Let's laser focus in on the platform engineer. It is that team's job to provide the best infrastructure, the best platform for their given applications, for their teams. What are some signs or signals for platform engineers to think about when it might be time to consider a cloud development environment like Coder.com?
So as a platform engineer, developers might constantly be opening like IT tickets that their computer isn't working properly. They might constantly want to update dependencies, but that's a big mess. You constantly have to email people across your team to say, hey, Adam, could we update from Java 17 to Java 18? Those are the kinds of problems that people typically have. That's the status quo. You ship people more powerful laptops to improve the build times of your projects. You try to reduce the complexity of your products instead of simply, leveraging better hardware. We believe that the future is leveraging the cloud for a lot of these things. You can get more powerful instances in GCP or AWS that can make the build times faster instantly. You can let one developer create a standardized environment and then distribute it to 1,000 so that when you're updating from Java 17 to 18, it's just a simple pull request. You can co-locate your servers right next to something like S3 or a database that you're using in development so that you get immediate data transfers and it's not slow. Many of our customers, which is a crazy thing to say, but they use absolutely massive monorepos and they get clones that go from like 10 minutes or 20 minutes or an hour to simply like a minute or 30 seconds. It's just a lot simpler when all of your engineers are standardized on one centralized piece of infrastructure, and then one person can impact the lives of hundreds of engineers. And with that, we don't believe that everything belongs in the cloud. We think that some workloads are really amazing for it, and some are absolutely terrible. Coder should be a self-serve offering to your engineers. It should not be prescriptive, where you migrate all pieces of software development into the cloud. Only the things that really get a lot better by running them in this cloud-native way do we really promote moving.
Well, it might be time to consider a cloud development environment. And open source is awesome, and Coder is fully open source. You can go to Coder.com, get a demo, or try it right now, or even start a 30-day trial of Coder Enterprise. Once again, Coder.com, that's Coder.com, Coder.com.
What are you guys both most excited about with the future with this startup? Because it sounds like a really cool idea.
I think for me, it's we're hosting a SaaS with our own product, which is certainly unique. There's not many companies doing something like that. And that was awesome. What a milestone. And now we're in the management phase, and we're still kind of learning how to effectively manage what we've built, which is pretty fun. And it's I can't wait to, I was talking about actions earlier, and I think that's absolutely a cornerstone of the fun bit of the product. You could have created the infrastructure in any IAC tool if you wanted, but you can't interact with it the way that we're doing it. So we're in my head, I'm thinking the interaction phase. How can I manage it super flexibly and interact with it and manage it in ways that I couldn't before?
What was something surprising while you were building that out that you're oh, the tool can't do this thing that I need, or we should be able to do, or we were able to do with other tools?
Traditionally, you write some IAC, right? And it represents your infrastructure. And it's cool, archive that, right? Now I'm going to write a pipeline to rotate all my EC2 nodes, or I'm going to write a pipeline to shell on, do something, various other things. You know the deal, right? You've run GitLab or Circle CI, and a lot of those interactions you can just do directly against the infrastructure in a pretty nice way. So imagine what you wanted to do was run a health check, and then when the health check passes, execute something. So we can orchestrate that. It's not really a pipeline management tool, but you can do some of the pipeline orchestration directly against the infrastructure in context, if that makes sense.
You bring up an interesting point that I think has kind of been repeated with tools over the years, at least from my experience, where early on config management days, it was oh, everything's going to be Puppet or Chef. And that's the source of truth. That's where everything needs to be declared there. But then people would go around it because actually, I don't want to learn Puppet module syntax, or I don't want to learn Ruby to do this. So I'm going to go do it in Bash, and I'm going to do it somewhere else. And I'm going to have a for loop that does this thing outside of the tool. And then your source of truth is no longer the source of truth, right? It's true enough for some things, but not for everything. And that's happened with that happens with containers. Like people can shell into a container and change things, and it happens in Kubernetes, and it happens over and over again because the source of truth is not holistic enough for the entire environment. And that's not something that, like, System Initiative is still, it's the source of truth for the things under its control, but I could still go in and SSH and do those things outside of it, right? So
of course, yeah.
What makes System Initiative a better source of truth?
Here's an example, right? You've got a security group, okay? And the security group is allow all traffic on 80 TCP.
But for some reason, it still doesn't work. I still cannot hit 80. Why?
Yeah. Security groups are the bane of my life. It's always the security group, if that's a rule.
Or DNS. Don't forget DNS.
Yeah. Okay, fair. And it's like, we've got these things internally called like refresh functions. So inside the application holds a state of what that resource actually looks like inside AWS. So it hits like AWS, EC2, I think, security group describe, and then the ID, right? Pretty much. And then it holds a copy of that JSON representation, again, directly against the asset. So imagine you have an incident, all the houses are on fire, and it's like, it's always a security group. Well, I don't know. And somebody changes it in the incident. You could see that in the resource definition in that panel. There's still some work in the future for us we've got this thing called the attribute panel, which is basically like user inputs. And when you created the security group, you would say 80 TCP, right? And then the resource representation in JSON would have that additional security group that was added during the incident. We're still working on how we would sync that back into a user managed attributes, but you still would be able to see the representation that, hang on a minute, we had an incident, we changed something, and like, should we put it back? So in System Initiative, it kind of exposes that delta at some level, and you could rerun the action that's like, oh, whoa, update security group, and it would push it back to the original.
And like, that's the thing that with all of these tools where something changes outside of something that I originally had intent to change, right? Like if I'm running Puppet on a host and I say, put this file on disk, right? Like I'm not managing Etsy hosts, but I'm doing resolve conf, right? And so once someone changes Etsy hosts, it breaks me, but my Puppet manifests don't know anything about it. Cause like, I wasn't looking at that file. I didn't touch it. That's not me. That's something else manages Etsy hosts. And the same thing happens with these tools over and over again, even with cloud APIs, where like, if I'm setting the security group and I had 2 rules on it and someone adds a third, that rule wasn't me. Should it also manage that? Or I guess in some case, the refresh function is going to say, this is different, right? It knows that something changed and it has to find an intelligent way to say which pieces change, because everything changes all the time, right? This isn't like this is easy because one rule changed in my environment. It's like, no, there's logs going everywhere. There's things that just change. Instances come and go. How do you do that intelligently?
So, like, I think if you think about the Terraform version of this, when you do an apply, it's like a 3-way diff, right? It's what's in the code, what's in the state, and what's reality. And you have to like smash everything together and go, if there are changes that aren't in the code, we need to get rid of them, et cetera, et cetera. It's just another way to describe the same problem. Like the product doesn't do it today, but it's very realistic that we could get to a point where we're just periodically refreshing and looking at changes in the environment and just saying, hey, this is different, and how it could surface to the user. You know, maybe that's a choice. Maybe some things it has like auto reconciliation where it's like, if somebody adds these rules, delete them. Or maybe it pops up and says the environment's different than what you've said here. Do you want to make the environment look like what's here, or do you want to make here look like the environment, to try to make it like a real-time representation of what's actually up there? And you kind of make a choice then, what's the source of truth? Is it the infrastructure or the representation of the infrastructure?
And that's the Kubernetes control loop model, right? Where it's like, oh, I own this deployment and that owns replica sets and that's pods, and I will make it look exactly like this spec over and over again. And then that's been extended, right? To like crossplane exists as a thing that creates infrastructure, and it has control loops that say, oh, go make that security group for me and reconcile it over and over and over again. And the two things that I've really struggled with is one, API limits in any cloud.
Sure.
Right. Like once you're saying like, we're just going to refresh this all the time. And then you're like, oh, I have 100. Like once you have 2, it's fine. When you have 100, you're like, oh, guess what? The cloud doesn't let me do that. And at some level, you can only raise your API limits so far. And so you have to take a balance of like, well, what am I able to do? And what what is actually like possible, right? If I own, and that's, I think Kubernetes did a good thing here of like, it tries not to by default manage things outside of itself too much, or at least not in reconcile loops. Like load balancers are one of those things where it's like, it will constantly check those, but it tries to do it in a way that's like, I'm not going to hit API limits for load balancers. But the second thing is that copy of what is true, right? That diff of like, what is the state? What do I think the state is versus what does the cloud think the state is versus what does the Linux file system know the state is, right? Like there's like all these versions of truth around, and reconciling that is always computationally expensive.
Sure.
Right. At some level of complexity or some level of scale.
Yeah.
And I don't think that the Terraform shove a JSON file in S3 is the right, necessarily the right model either. But I also don't think that it's etcd. And there has to be some other like middle ground to make it so like, oh, this is truth enough that this isn't going to fail for me, or I don't, it shouldn't, or it should fail fewer amount of times.
I think what's very different about what we do is that ours is not really a 3-way diff. It's like a 2-way diff because we don't have a code representation of the infrastructure. Like what the UI is serving is the representation. And in the backend, it's just a giant graph. And like the graph has nodes and edges that describe all of the different components that like build up what you actually see. So like it's a diff between those two things. So,
but the UI representation is like some form of code, right? Like I'm not like writing HCL, but like it does need to diff that into it's Postgres under the hood, right?
We store like the actual data of like a node on the graph gets stored in Postgres, but the actual like graph itself, like the whole thing, it's stored like piecemeal, basically. And like addresses to nodes are stored in Postgres, but it's not like a relational database. It's like a math, like I don't know how to say graph without saying graph.
Are you using, is it a graph database that's putting information like that, but the actual information from those nodes are being stored in Postgres? Like,
yeah,
like Wiz is built on a graph database. Like, is it the same kind of concept, I guess?
It sounds similar. Like the actual like information from the nodes on the graph, they're just an address, and like the actual like hashed, like serialized and hashed bits are the address, and like the rest of it's just shipped off into Postgres or in memory or on disk. Like we have layers of where we store them. Yeah, depending on like how quickly you need it.
Your actual graph, is it a database? Like, I guess, I don't know. I guess it's a data structure, but like they actually have graph databases. Is it like?
No, probably not in the way that you're describing it, or a misunderstanding, and I don't know.
And that was one of the things I was like curious, because like Postgres is storing the data and then the application is putting the like links between them, right? Is that because it's not like not Node.js, what's the Neo4j, right? Like Neo4j as a graph database or the graph database layers on top of Postgres isn't what you're actually doing. You're storing the data and metadata about the endpoints, and then you're linking them together in the application.
Kind of, yeah.
Yeah, because some like applications will actually have like a graph database like Neptune or something, and then I guess it could either just store it in Neptune or it could store it somewhere else after. But it holds all the relations between the different entities.
How is that different than storing that in a JSON? Like you said, you could store it on a file system. So I could store this on a file system, and then if I squint, it looks a lot like Terraform. Like at some point, I'm like, oh, it's a big JSON file, and then I can pull out the nodes out of it. Like that's what I'm kind of trying to reconcile in my head.
The graph would be more accurate with you changing it on UI, I'm guessing, and keeping all those relationships straight and accurate, I would think.
Yeah, you could make arguments about like, are you transforming HCL into some other representation on the back end? Like it's not human readable, right? It's like a data structure. I mean, I guess it's human readable if you try hard enough, but you know, yeah. So like it just gives us access to being able to like walk the graph and do diffs about the relationships of the things that are there, understand conflicts, and like know how to make changes between change sets. We have a model very close to Git where you have like a head, and when you want to make changes to the infrastructure, you open a change set, make changes, and then basically push the changes onto the graph, and it like reconciles and does what it needs to make that the new reality and push it up to whatever cloud or whatever you're interacting with.
How do you make sure it's all secure without kind of shooting yourself in the foot at the same time? Because I feel like it's either like every automated security or automated anything, it's like you want to automate things to make your life easier, and then at some point it makes it harder. So like, how do you reconcile all of that?
It's very hard to keep it secure. That would be my honest answer.
You're giving something the permissions to make things and delete things and interact with each other. So like, how do you...
You mean between the components in the graph?
Yeah.
So it's more
I mean, not just that, but like it's making those, like it can make an EC2, right? It can make all these like different infrastructure pieces. So how do you then keep them secure that like something can't go in and, I don't know, make 100 EC2s on one of your accounts, or you know what I mean? Like a bad actor isn't doing.
So the hardest thing probably for us as a company to protect from is user written code, like unprotected, just raw TypeScript or similar that we execute on behalf of users. And that's why we went down the route of Firecracker, because that's basically the Lambda model, right? So we could have went for something like, I don't know, a Kubernetes deployment running some pods, and each function runs inside its own pod, right? And we felt that this Firecracker model will scale better and should, in theory, because of the VM layer in the orchestration, should be more secure for us and our customers. So security on that front, I think, like all of the networking rules are written, like we've done it basically from absolute fundamentals. There's no networking controller on a node for us. There are specific IP routes that are permitted for each VM, through to public access, through to the OTel collector. And there's absolutely no way that is, I don't want to say realistically feasible, but there are inhuman people on this earth that might make it possible to cause like east-west traffic between different function executions. So it's basically impossible for them to interact with each other within reason. You're asking like, how do we protect from the components influencing each other? That's kind of what you're asking.
Well, I mean, also a human can be like, I'm going to go, and I feel like it's weird how sometimes customers will use your product and you think they're going to use it in a straightforward way. And then all of a sudden they're like, we want 1,000 VMs. And like, you don't want them to take down someone else in the process, or a malicious actor to just DOS attack you, or,
I'm very fortunate because Scott is great. And I've never looked at what he's done in our workspace and be like, dude, what is wrong with you? So that's amazing. But so each, we've got this concept of workspaces and change sets. So I hope this answers your question. Basically that if you're collaborating on a change set, so imagine Scott's doing the security groups, I'm doing the compute, and we want to create this infrastructure, a bit like the way you would Git apply it to head or Git apply it to main. It would be like, I try and apply it. It'd be like, Scott gets an opportunity to review it before it goes into head, and that stuff actually gets created. It's a very Git-like model. And there's we're still to implement, or like there's a bit of work that needs to go in on RBAC. So a bit like, different roles like viewer, editor, I don't know, applier. I don't know what they might be called. But, that would improve that kind of posture, a bit like you've got in Git.
And from if let's say somebody starts using the product and they try to create 10,000 EC2 instances all at once, I mean, we have pretty like rudimentary resource limits and things on the size of the VMs that we create, and like throttling on how many we can run at a time. So ideally, all that happens is that it takes a long time for them, and other people aren't really slowed down by it. But that stuff can always become more sophisticated, and we can do rate limiting and try to distribute workloads and that kind of stuff as well.
One of the things, Scott, you mentioned earlier about making the diagram the infrastructure, or the more truth infrastructure representation, is I love drawing and diagramming. And every job that I've had, when someone's like, I'm describing a thing to me, like, can you draw me a picture? Because I want to see it. I want to see what you're talking about, and I want to understand it better in a picture form. But one of the things that sucks in pictures, and I've never found a good way to represent it, is things that happen over time, right? Things that need to happen in series. And I used to work in animation, and I loved animation for this. Like, I've started drawing my own animations of like, this is how this thing changes, because it's showing you the thing over time. And one thing we can't do easily in a static representation of a diagram is like, I need to go from architecture A to architecture B. How do I get there? And in our heads as administrators and architects and as, developers, like, we know the steps that we need. And I'm assuming you would have to build some of that logic into a function that owns that migration process. If I'm migrating a database or something, or I need to do table schema changes, right? Like, the database can handle most of that stuff, but there are things that's like, oh, well, I have to do this in a certain step. I need to make sure that application 2 is deployed everywhere. I need to make sure that the database schema has migrated, and I need to make sure that application 1 is gone, right? Like, you need to do those things in an order. How does System Initiative handle things like that order for things that have to happen over time?
Sure. It's a good question. The way things mostly work now is determined by the relationship between different nodes. So like, if I have a VPC and I have subnets and I have route tables, and I want to create all of those at the same time, the subnets rely on output from a VPC. I need the ID to know where to create the subnet. So like, just that relationship alone is enough to tell us when the create actions, for example, need to get run.
So if I want to delete a VPC, you're telling me System Initiative can properly find the ENI that's still stuck attached to an EC2 instance and delete it properly?
Theoretically.
I don't think that's possible, but it would be lovely if that actually happened. I said delete the VPC and actually everything, it cascades properly in order.
If it's on the graph and you can see it, like, you can queue up the deletes appropriately and like make it go. We're still limited by the nature of physics and AWS APIs, both equally limiting. But yeah, a lot of how things work today is just based on relationships. We've talked about more sophisticated systems that like let you describe something, maybe like a workflow, or to define the order of actions and maybe make decisions about run action B if action A fails, those kinds of things. But for the most part, it's just like, I need this to exist before I can make this next thing. So I'll wait till it exists, take the output, make the next thing, and just kind of walk down the path.
And that still assumes that I'm the creator of those nodes, right? Like, I can't point it at my AWS account and say import, right? Like, let's just go figure out everything I made, right? Or can I?
Not yet, but That's definitely something that we want to do, both like importing existing infrastructure. Like, I want to pull in a single VPC, or like, hey, walk through my account and like bring it all in and show me what it looks like. I feel like that's kind of like the dream. We have all the things in place, right? Like, we have the ability to, like, running a refresh means basically going and getting information about it. So I think we can get there. I think it'd be really cool.
Yeah, and that makes a lot of sense to me. That it was always kind of the dream of Terraform to like, hey, you technically could do the same thing of Terraform, go look at the API and then spit out the HCL that would give me that thing. But a lot of times how those things are structured dependencies wise of like, I need the variable from here to go into the variable of the other thing, is not a direct one-to-one. In Terraform could either go everything's a variable or nothing's a variable, or it makes that like, how do you tie those things together is really difficult in a textual code representation.
For sure.
And it seems like it could make a lot more sense in a visual. These things are linked. Whether you need it to be a variable or not doesn't matter.
Yeah, absolutely. I think it makes a lot more sense in this kind of model.
I really want to reflect back on what you were talking about, Justin. Deleting a VPC, there's an EC2 and a subnet, and there's an ENI attached to that EC2 instance, right? So
the struggle is real. This is
that's a legitimate infrastructure problem. Okay, so within System Initiative, we have these things called edges and nodes. Okay, so edges are basically what you can connect between different nodes. So your EC2 has an edge for subnet, and that connects to the subnet ID of the subnet component, if that kind of makes sense. So imagine in your world, you're like, right, if I try and delete that whole thing right now, there's nothing that tells the ENI to delete first because there's no edge, okay? And what you would do in System Initiative, you'd select the whole frame, you'd hit delete, and it would fail, okay? And then as a user, what do you do, okay? You're empowered to go into the authoring, add the relationship, like add the socket to both sides of the equation. So you would add it to you could put it on the VPC, for example, and you'd also put it on the ENI, connect them, and then the system would understand the relationship in that graph database between the two objects and be able to orchestrate the delete more effectively. Imagine it's like, I'm pretty passionate about this because it's like super empowering, right? You can legitimately fix that problem in like 10 minutes, contribute it back, and then everyone benefits in the same way you do in a similar kind of manner to Terraform modules. It's just a lot less like tedious, and you can see the result just like super quick.
I don't think we have enough time to dig into that collaboration model, because I do think that's really interesting. Not only the collaboration in contributing back to those functions, but the collaboration of two infrastructure people looking at the same diagram and acting on the same change set. What's it called?
Change
set, right? So like being able to do both of those things adds a lot of questions to me. Like contributing back a function in System Initiative to say like, I want to extend this, immediately in my mind, working at enterprises for 20 years is like, do I have to get approval from OSPO for this? Like, is this code contribution? Like if it doesn't go through GitHub, am I still doing the same thing? Right? Like all of those questions get answered to me as like a process and open source, quote unquote, like person. What does that mean for my contributions into that ecosystem? But then the other thing of just like the speed of learning, of being able to basically pair program on infrastructure at any time with those sort of like share and collaborative links of like, oh, look, here's the picture. This is the change, this is how it's going to be different. Does this look good to both of us? And again, it's outside of that like Git PR workflow, which we've all come as like, this is the standard for infrastructure, is you have to make a branch, modify it, push it. Someone looks at your text and then says, yeah, it looks good to me. And you ship it. Right. And then something else breaks down the line that says, no, actually the state of the world was too different than what you thought it was.
So for me, when I joined System Initiative, Scott, you said you were like you didn't originally completely buy in. For me, I almost like was anxious that I couldn't do Git branch, write some code. It was safe, and it was like a static reference that I could look at. And, whereas in SI, you create a change set and if you think of the change set as a branch, it's probably very intentionally not called branch to not cause confusion. It's like a live simulation of what would happen if you merged it, like the values of propagating and stuff through the change set, like your IDs and things. And it would know that, that ID doesn't exist yet because the resource hasn't been created. So you can see that. And it's like almost made me uneasy, but once you use it, it was pretty amazing.
So, where should people go to get to try it, to get to use it and say like, hey, this is a thing. Like I'm interested in what you're talking about.
So we've got a community of amazing Discord users that you can join there and have a chat with us, join a call with us. And we're running like a pre-release for users, and you can drop us an email and we'll give you access and you can play and have some fun.
Yeah. So tell them the podcast sent you. And we'll hook you up.
The coupon code for free is ship it. And
the best part about John explaining that whole part that he just did was like, you can see the genuine excitement and passion that he has for it. Like he like leaned in and brought
the mic closer. He's like, you have to hear this part, right?
He leaned in, his face was excited. Like you can tell like it's really cool when like sometimes we just have to take a job and you have to do something that you're just, building stuff. But when you can be like genuinely excited and into it, you build like even cooler products. So it's really cool that you were like genuinely so excited to talk about it and passionate about it.
I would love to say I'm an amazing actor, but I suck at acting. It's genuinely really.
This is true.
Yeah. I'm really, really, really excited for some of the people I previously worked with and everyone in the community for SRE and platform to try it. And I'm excited. It should be good.
Yeah.
It's awesome.
Cool. Well, thank you both so much for coming on the show and talking to us all about System Initiative and kind of how that infrastructure works and how you're hosting it yourself. This is great.
Yeah. Thanks for having us.
Thanks so much.
It's nice meeting you guys.
Yeah, you too.
up, friends? I'm here with a new friend of mine, the creator of Bitwarden, Kyle Spearin. Bitwarden is well known as the open source password manager out there to secure your digital life. And now they have a secrets manager to keep devs safe, to keep secrets safe, secure keys, tokens, and machine credentials with easy scalable access for humans and machines. So Kyle, why is now the best time for you to launch a secrets manager at Bitwarden?
We've been doing password management for a long time. And if you sit back and ask yourself, well, what's the difference between a password and a secret? A password is a secret, right? A lot of it comes down to kind of the integration point of what we offer. Secrets Manager is kind of another platform of doing the same thing that you do in password management. There's a lot of similarities, and that's why it made sense for us to move from just doing password management into secrets management as well. We also have a very strong user base that is very centric to kind of our open source message and our developers themselves. So it very much aligns with who our core user base is that we tailor to. So Secrets Manager was a natural evolution for us to go into. Password management hygiene of users is really bad, and that's the problem we're solving with Password Manager. I don't know about you, but if I look back at my career and how I evolve, and especially developing new projects and other things, secrets management is also pretty bad hygiene, or especially in the earlier days for a lot of people. And you can kind of get into the rut of doing bad things, and you can permeate a lot of those kind of bad practices in a lot of ways to other aspects of your business that's important to stay ahead of. We think that it matters a whole lot to developers to use a familiar platform that they know and love and can trust to kind of solve their other problems that, clean up the hygiene of what they do on the internet and how they build applications and how they manage secrets across their applications.
Okay, get streamlined secrets management for developers at bitwarden.com/secrets. Get end-to-end encrypted Bitwarden Secrets Manager, clean up your hygiene for your secrets, secure your infrastructure, your machine secrets, and your developer secrets. Start a free 7-day Bitwarden Secrets Manager trial today at bitwarden.com/secrets. That's bitwarden.com/secrets.
Thanks again, John and Scott, for coming on the show and telling us all about how the infrastructure works and generally how System Initiative thinks about infrastructure. I like that they're self-hosting, or at least managing the SaaS version with the tool itself, because that dogfooding always works out well.
Yeah, I thought that was really interesting, the way that they're dogfooding their own product, which means I feel like you catch a lot of bugs and different things that way. And that your product, I don't know, it just makes it a more mature startup to me. But, because they're using their own stuff to run as a service.
Right. And when I worked at AWS, everyone came and told me all the things they hated about AWS. I was like, you don't hate AWS as much as the AWS engineers, right? Because AWS was built on AWS and they know all of those edge cases as much or more than any customer. And it's one of the superpowers that I've always thought that's AWS has over other cloud providers, where AWS is built on AWS, almost all the way down to the bottom, right? There is a layer that is just raw infrastructure, but GCP isn't built on GCP. It's built on Borg.
It isn't?
And Azure isn't built on Azure. It's built on Fabric Manager, right? There
really?
are some, they don't use their own tools, which I was always like, there's this disconnect around you should have access to this. It's no, you should just build on the thing that you're telling customers to build on.
That's wild. I did not know that.
Yeah.
I also think that there's you better understand why things are built a certain way when you have to use so you start building something, right? It's never a straightforward best practices way. You always try your best, and then there's something weird that happens in some weird edge case, then you have to fix it and iterate.
Right. And you build something for yourself to say, I want to solve this problem.
Yes. And then, but when you're passionate about solving that problem and it's a problem and then you use it, it's just you have a different buy-in to fix it, right? Yeah.
I think the big disconnect comes when customers they have different assumptions and different ways they want to work and different things that they want to do. And you're like, I built this tool to solve the problem that I had. And now a customer has a different problem. And now we need to expand a lot of those assumptions. And I think that's where it's really exciting to see how things have grown, and even things in the past like Terraform and config management tools. They've all kind of done this where it's they solved the problem and that a lot of other people used it and did bad things with it.
I don't think they talk about that enough when you're going to school for being an engineer, about how you can have all the good intentions in the world and then somebody uses it and you're like, but why? Like, but also I think when you're building at a certain scale for you to use in dog food and then you make it like for open for other people to use it, you're always going to get a lot of different edge cases at a scale, like if you could have customers using it, but if they're not using it at a certain scale, it's always going to be, I don't know, hiccups later when it gets to a bigger scale that you may not have.
Or just like the boundaries around a tool. Like it's hard to draw those boundaries because you're like, I want all the customers.
Exactly.
And things like Kubernetes have been used for all these things. It's like, maybe you shouldn't be using Kubernetes here. Like maybe I understand you like how this functions or you're familiar with this, but like at this level, like just go do a different tool.
That's why this product, like especially is interesting, and just having a background as a solutions architect, like there's so many times where I'm just like, people are like, I use this, and I'm like, but why? Why do you use this? And then they're just like, they can't tell you why they use it, or they'll be like, I use this and I love it, but I have this and this and this problem. And I'm like, do you love it though? Like, like I think that you don't realize that there's other products out there. Like, and sometimes like it would be like a service I worked for, and I'm like, you don't know, this is not like the right database for you. And then they're just like, but like, it's not though. Like there's a reason we have all these tools, and there's a reason that so many tools are built from like compute power or like infrastructure tools or database tools. And there's such a variety because sometimes they don't always work for everything.
I mean, and like tools are sticky because you're like, I know how this tool works, so I'm going to stick with it. And problems are often invisible because we get used to it, right? Like, because we built the problem ourselves and we're just like, oh, that's not actually a problem. And like, no one else has that problem. Like you built this on yourself and you should go use a different tool.
It's also why it's hard when you like internally build everything for yourself and you don't like, sometimes you want to have the old simple stuff that you built yourself. And then sometimes it's like, dude, at some point we need to like not build everything ourselves. It just depends.
And that's also hard, like, because there's fundamental pieces of that tool structure that are old and crusty and useful, but also are so esoteric that they shouldn't be used, because they're also like, you can use the new and shiny and not have anyone come in and know how this works, or you can use the really old and crufty and not have anyone come in and know how it works.
Dude, right? Nobody talks about that struggle. Nobody talks about that. Like, you're not getting kids out of college that know how to do in-depth bash. Like,
right. I was working for years as an engineer, and like I found out that like one of our fundamental tools at this company was built using stow. I didn't even know what the stow command on Linux, it makes a bunch of symlinks for you from a file system, and it stows things in a directory hierarchy. And I didn't know what this was. And it was a foundational piece of most of what we were doing at this company. I was like, I didn't know this existed. I did not know what this was. I don't know how this, there's just so many, I'm sure, edge cases around, like someone's like, you probably shouldn't use this as a tool for this thing that you're doing. And we were using it for like the basic intents, but at a scale that I don't think a lot of people were doing. And so those sorts of things are also edge cases where like, yeah, maybe like sometimes you do need to move off of an old thing. Yes.
And it's hard to know when everything you have is built in that, or, you know, like you've been doing it for so long.
So for today's outro, we're going to talk about a couple books, like some longer reads, some things that are kind of recommendations or summaries around a thing. And since I teased it in the intro, I'll go first because my book is called Darkwire. And Darkwire is a book all about how the FBI in the United States ran a quote unquote secure phone network, mostly for criminals.
Oh, this is so shady, but I love it.
Like, it was kind of amazing. And it was I was interested in the technology aspects of it from a book perspective. And it obviously goes into a lot of the stories around like the horrible bad things that criminals do when they think no one's watching. Right? Like if you're a bad person and you're like, no one can ever see my message, then I can plan anything I want. And a lot of it was talking about like large drug deals, but also like kidnapping and killing people and all sorts of different things. I was like, oh, this is interesting. But the fascinating thing about it to me was the fact that like, this was literally the entire startup. It was a quote unquote startup that ran a cell phone network that had their own devices. And they said, this is all the way secure for you. Everything about this is secure. And then they had a back door that just sent all your messages to the FBI.
That's wild.
So every message they sent was sent back to the FBI, and it started in San Diego. Like these people in San Diego were approached by someone, an old secure network shut down because they got hacked, I think, by the French government. I'm losing some of the timelines, but basically, like there was competing secure networks. One of them shut down, and they all kind of fled to Anam, which was the network that the FBI ran. But then also like another network shut down, and then the FBI went after another one and closed them down. So everyone had to flee to their network that they were running. They're like, we're the only secure network left.
That's genius.
And the reason they shut it down, and this was like 2 years ago, they shut it 2022-ish. They shut it down. It ended up being the largest worldwide sting, like arrest in a single day ever in history. Because they got all these people, because they said, they're like, actually, the problem is we're too successful. This startup that we're running that no one knows is run by, like, people that worked at Anam didn't know they were like,
what?
They didn't know. Like all these messages went to, like, they thought they were working for enterprises, and enterprises want backdoors into messages. And they're like, oh yeah, sure. We'll add that feature because it's enterprise. No, everything was going back to the FBI. So engineers were building this stuff that were like, oh, this is cryptographically secure. It's going to go over here. And then it gets.
What? So they were working for the FBI and they didn't even know they were working for the FBI?
Yeah. So like it was completely hidden.
That is wild.
And so the thing is, they were at this point where they grew too much, and they're like, this startup is too successful. Too many people are going to know about it. And they started giving access to like different governments around the world in different ways that like other people could see, because as an FBI, like they weren't allowed to wiretap US residents, but the rest of the world was game. Right. And so they were like, oh, this is for everyone else. And they were like sending like hints to other people, like, hey, you might want to go check this container at this port. It's loaded with drugs.
Have you ever seen the show American Greed?
No.
Beth would love that. Tell her about it. But like,
I'm sure she would.
It sounds that is just wild. Like I feel
like
it's American
in
Greed,
real life.
But, yeah, but like, well, it's about real life, and it's like different. Like it'll be like crazy. It'll be like this guy like BS'd his way through being a surgeon, and now he's like operating on like patients like as a neurosurgeon. And then one's like this dude like put a huge life insurance policy on himself and decided he wanted to leave his family and crashed his like plane and showed up like 10 years later. It's wild. But it's like all these really crazy like things, but that sounds like that, but with technology and the FBI. And I'm just like, I would totally read that book. That sounds wild.
Yeah. The like secure side of it was really fascinating to me, of like, oh, this is just all backdoored and how it worked. And really they picked a date, and they're saying like, hey, this is too successful. We have too many messages and we can't go through them, and we can't be responsible if someone's going to try to kill someone, to be like, the FBI got this message and we didn't do anything about it. And they're like,
I wonder if that was like so stressful. Can you imagine seeing all these like messages and you can't do anything about? Oh my goodness.
And there's not just like, there's pictures, there's everything, and they get all the metadata about who they called. So they're building these networks out of being able to see these graphs of how people communicate.
I feel like that would be very interesting, but also like, you know, they talk about how like therapists or like, you know, like nurses like take on a lot of that like heaviness,
that burden.
Yes. And like just like the Facebook moderators, like, you know how they have to have a human moderator for some things? Like, can you imagine the things that they saw and that they knew were happening but had no control over stopping?
Yeah. And so they literally they said, hey, everyone that knows about this, we're picking this date. And I think it was like June something. And they're like, we don't care if you're ready or not. You get ready. They gave him like a month advance or 2 months of it. Like, here's all of the information about all the people that we have for, like, you should probably go check out. Right. And so they had like worldwide sting of like thousands and thousands of people that were just like, oh yeah, no, like we got all your messages. And they had to find, in a lot of cases, like court cases, those messages weren't good enough depending on country laws and stuff, because they're like, oh, well, this wasn't a legal wiretap, so they had to get like real world evidence. So they had to stalk people too. I'm like, oh, I know where they are because I have GPS from their phone, which they don't know that I have, but I can go take pictures of them doing this deal or whatever. And so it was really interesting, and just like how pervasive it was and how much nobody knew, and everyone thought this is the most secure thing.
You know how it's like one of those things where you're like, if we just had more information, we could fix all this. And then all of a sudden you have too much information, and you know
and
what I mean?
They gotta shut it down. Yeah.
Like I it's like almost like I hope they find a better, efficient way to redo that at some point, because it seems like it could be a lot of good, but at the same time, like you could see how that would be very costly, but also just like heavy, like a human toll also.
Yeah. And I mean, there's so many questions I have about just like legality of a lot of things. You're like, oh, this is other countries, we don't care. And I'm like, this is humans. And I don't know. And then I think of like,
well, not just that, but when they say that they don't wiretap like Americans are just like, and the fact that like you would then have so much evidence to justify getting, you know what I mean? Like you started off wrong, but at some point you could definitely have a roundabout way of gotten enough information to make it legit.
In the book, they call it that like they even had pieces in the software to like remove people or not track people. Like I don't want their messages because they were like, oh, actual like lawyers are using this that for like just client confidentiality, and we can't have that information because that does violate a lot of things. So they were saying that they're like, oh, we had these things that like these numbers, we don't track GPS, and like you have to trust people at some point. Like maybe not, I don't know. Like you just lied to a lot of people.
I feel like certain keywords and stuff, I'm just like, if you're hurting little kids or like doing horrible things, like it should just be fair game.
But that was my book. It was really interesting just as I wish it kind of went more on the technical side of things.
I'm going to go read that.
But I listened to it and it was a fun, just kind of like as I was doing dishes and stuff of like hearing what was going on, but also it was also just really kind of depressing because I'm just like, oh, this wasn't fake.
See, I don't know, like as a mom though, like, you know what I mean? Like, I don't know if like there's some things where like I had to stop watching as many ID shows because that was just like, it was giving me more anxiety. Like it's so interesting, but also like the world is horrible. Like, I don't know.
Yeah.
Okay, so my book is A Mind for Numbers: How to Excel at Math and Science, even if you flunked algebra. But so what I really enjoy about this book is it teaches you how to be a more efficient and effective learner, and it talks about like why your brain needs certain things. Like I know it talks about science and math, and that doesn't seem as much software engineering, even though there is a lot of obviously computer science and like math and engineering. But I love that it talks about, for one, very like famous big thinkers. Like it talks about Thomas Edison and how Thomas Edison came up with these clever tricks, and then Salvador Dali, the artist, ended up using some of his concepts, and like Albert Einstein and all these great thinkers. And like if you look back at like Albert Einstein, for a long time, Albert Einstein was not successful in physics. Like he actually like got a bad grade in high school, and then he worked a crappy job that was like doing patents, and he was miserable. And then like he went from getting a bad grade and like out in physics to having the theory of relativity taught. So it's like, I think it's really encouraging for people whose brains work differently, or you think it does, but really in a sense, like essentially like your brain is doing what it needs to do to process it. So it's like just really interesting, like taking breaks or just doing things that your like brain doesn't need to think about. Like I would always be like, oh, I have to go pick up my kids, or I have to go like, you know, do some chore or something in the middle of the day. And like, oh, I wonder if that makes me a worse engineer. But really it probably makes you a better engineer, that walk that you take, because it helps your brain to do all that stuff like in the background. But it's just so many different cool ways of like how to be an effective learner, how to like, it's cool to see how many like things that maybe your brain's doing that maybe Albert Einstein or some cool thinker that you may really admire also did. So I really enjoyed it.
Cool. I like their cover. I like
so
the
cool.
like the math equation.
Yeah.
On the cover is
it's a really good book, and it's not boring. Like I don't know. I think a lot of self-help books are icky, and like a lot of like books about, I don't know. This just book is like really fun. It's got a bunch of it's weird to say it's fun about learning, but I like learning. But you know, like it's just a lot of really cool historical things and just ways that people use to kind of hack their brains, that you can also use those tips and tricks and, I don't know, maybe validate.
You would probably like the book Thinking Fast and Slow by Daniel Kahneman. Fantastic book, but it is a really big book.
Oh, see, this one's not that bad.
Yeah, Thinking Fast and Slow, like I read it once and I want to read it again, but it's like an investment.
See, I've read this book more than once. I haven't read the whole thing, but I keep reading different parts, and I'll probably read it all the way through. But like this book and me, look at this book. It's been through some things. Like this is like one of like the best $9 I've ever spent, because it's like, I think not only is it just learning tips and tricks, but you're also like, it validates what your brain already does. So like you kind of let your brain do its thing more.
Yeah, and that's exactly Thinking Fast and Slow. Where Thinking Fast and Slow as a book is explaining, because he has like Nobel Prize or whatever for like his research on how the brain works. And it's literally like when you're talking to someone, interacting with someone in real time, that's thinking fast, and you have to think of things without thinking about them, right? Like you have to just say something without thinking about it. But then when you go and marinate on something, or you write like one of the things I love about thinking slowly is writing documentation and writing things out, because it makes me just slow down to the keyboard speed. Like how fast can I actually type something out? And that just makes me have to think of my words better and think of how clearly those ideas connect. And thinking slowly about stuff is a different way of going through it.
Also, that validates a lot of like, think about like learning engineering in theory and then actually using it, or like when you learn a concept in theory and then you have to teach it. Like it's always a like different it's a different way deeply learning something. So I think all that really supports that.
A Mind for Numbers sounds really familiar to Where Good Ideas Come From is another book. And I actually, this one's shorter and sounds a lot aligned with like, it talks about real world people that were doing things and how.
Yes, that's the part that I really enjoy. But it's also wild. Like my son's autistic, and just finding out like how many people like Sebastian Bach, Beethoven, Albert Einstein, like I think like as a neurospicy person and growing up with like, like, and like when we grew up, people, it was like, you were just like the weird kid, or the kid did stuff like unconventionally, or like I would always solve math problems completely different than everyone else would. And they'd be like, well, that's wrong because you solved it a different way.
Right,
and I'm like, I got the same answer and I was faster than you, like, yeah. So it's like, and then seeing the way that my sons are growing up now that we know more, it's wild, because it's like, I think we got made to feel bad for being like the like neurospicy kid. And then you find out like all the best inventors in history were these kids who thought differently, So it's cool to see like how so many great thinkers and revolutionary like inventors also think differently.
And the Where Good Ideas Come From is all about that crossover, right? When you're going from like, I know this field really well, and then I'm going to go do something else. And you're like, oh, I can apply some of the things I learned in this completely not the same field into this new area. And that book goes into the things like Darwin wasn't like a biologist. Like he started learning other things originally, and then he's like looked at animals and he's like, oh, actually, what if this is related to that other thing I was doing? And like, what if like evolution happens in animals too? And that sort of like notion of just like these, how you pull things from other fields that you were an expert in, and you just like find things on the edges is where a lot of those ideas come from.
Which is also wild if you really think about where like things are going in tech right now with the whole talk about DI and like, like people, I feel like we all know that our interviews suck, but that's how we interview, like with leak code and all that kind of stuff. But how many people are you missing out on because their brain is different and they may not, you know what I mean? Like, but those are the people that could completely change and build that really cool product, or, you know what I mean? Like how many cool people do we meet at like scale and they've got like a theater background or some other background and they are amazing engineers, and like how many of those people will we lose out on with this whole like new attitude,
Well, I was like, there's two sides of that, right? Because like the people that you don't hire because they don't fit the mold of what you think is a good functional person inside your organization, but then also the people you do hire and don't listen to.
Yeah.
Right. There's two sides of that coin of
that
just like, oh, well, you're in
true.
the door, but we want you to fit this box and you don't go outside of that box because I don't want your ideas about how that product could change.
I've experienced that a lot. I think that's very valid. That's something I would not have thought about. That's very valid.
And that's something that like I've been in enterprises for 20 years. I always struggled with that sort of process and what my boundaries were as a developer, as a system engineer, whatever the title was. They're like, that's the box you fit in. Don't go talk about this other thing. DevRel kind of expanded that a little bit because I was like, oh, I'm in product and I just got to go like learn new things, which I really enjoyed, but it didn't have impact on the product backside of things. And that's something I'm learning more about at a startup, first time at a startup, where I'm just like, oh, like I can go have impact anywhere. And I don't have the same boundaries around my title or my impact and ideas, which has been a lot of fun for me in the last 8 months.
I think that that's one of the coolest part of the way that your brain works is you're always like, and I tried this cool thing and then I did it and then I learned this. And I'm just like, how many companies lost out on the way that your brain works because they tried to fit you in a box, you know? Like it's crazy what people will sleep on because it's not familiar to them.
Right. And I mean, you see it a lot from especially large tech companies where people leave and they go to a startup because they're like, hey, they didn't listen to me for this product and now it's $1 billion company. Right. And for some large companies, they're like, that's not us. That's not our identity. We don't want to do that thing. We don't want to be associated with whatever. Like there's plenty of reasons, but then also like it's money that you could have had that you don't have. And maybe it's not enough money for large companies to care about, right? Like millions of dollars to a big enterprise is like, like I could save that if I just deleted my VPCs properly, right? Like
doing the VPC delete,
bringing it all the way back. I was just like, yeah, like you can save that money anywhere.
I love when you throw a little bit of shade. It makes me so happy. Like,
yeah. So, but yeah, no, I do think that like where good ideas come from is one of those books that I've read multiple times, and I'm like, this is fascinating how this works. But yeah, Darkwire, mine for math sounds interesting. I have a math degree, so I'm kind of like,
I still just like my brain just hurts when I think about that you went to school for a whole ass math degree. Like,
well, like, but like I started from the beginning. Like I had no math background, and I started from like algebra 1 in college. And I was just like, wild. I don't know any of this stuff because my high school was really bad apparently and did not teach me any of it. And so I was just like, hey.
Me too. They were like, we're going to try this new math in Hawaii and like a school that's not already like, that's already sucks. And then they're like, oh, it was terrible. We're going to change.
We're not doing that ever again.
Thanks. Like, what do you mean, sir? Like,
hold on a second. This is still how I do. Yeah. And like for me, like I went to a private school and the high school doesn't exist anymore. Like the school was so bad that it shut down. But like my wife went to public school and like when I was talking to her, met her in college, I was like, what did you learn about? Like, I don't know any of this stuff. And I was just like, oh, my school just didn't teach me anything.
So they paid extra for them to not teach you. See, this is...
Well, yeah, my mom was a teacher, so it's like you get to go to the private school for free. If you,
okay, good. At least she wasn't paying for it. Like,
yeah, it was one of those like loopholes of like, oh, you're rich. And I'm like, well, no, like my mom's right there.
Dude, well, because it's funny, especially having like neurospicy kids. It's crazy. Like, I'm like, I could send them to these expensive private schools or like, but what are you really getting? Because there's no like programs for kids that are neurospicy and those private
there's so
schools.
Much less resources in that environment.
But you're paying like college money. Like it is wild.
And yeah, anyone that talks to me that's like, oh, private schools have better educations. I'm like, I am proof that they are not. Like, that was not my experience. I went to private school from 5th grade all the way through college and got my master's degree. And I'm like,
and I bet your mom probably like stayed at that school, at that job, so you could go to that school too.
Oh yeah,
you know?
Absolutely. Like she was there for a while so that me and my sisters could go to that school.
And it's wild because people are over here working 2 jobs to like put their kids in those private schools, you know?
Yeah. And then I talked to my wife about all the things that she learned in public school from the education in the classrooms and outside of the classrooms that I didn't learn about. There's so much more to learn in high school. My class was 42 people, my graduating class in high school. And it's just like, I didn't learn a lot of things.
I think we were like 500. That's wild. And I was on a tiny island, Justin. What was going on?
So it's fun. But yeah, just we wanted to go and share some books that we recently read or reread and were interested in for anyone else out there that is interested in those same things, because there's a lot more out there than just what's on the internet and social media.
I love a good book.
I listen to all my books. I can't read, which I also found out about myself fairly recently. But I have one of those, I forget what it's called, but when someone tells you to like picture something in your mind, there's no picture there. Like someone tells you like picture an apple, and like this, it's just black for me. Like there's nothing there. I can think of things about apples and like metadata about apples basically, but like I don't see anything.
Ooh, I like how you said that, metadata. That's wild. I just assumed everybody saw something.
And that's a lot of people like my whole entire family. They're like, wait, you don't see an apple? I'm like, no, like that's
how do you meditate?
I sleep.
My brain's just too loud to meditate.
I can't close my eyes and like not sleep. Like it's just
you are narcoleptic. Okay.
That's what it is. That's what it is. But yeah, no, like, and so like thinking differently about things is one of those things where it's just like, oh, like my wife is always like, I'm a terrible speller. And she's like, well, just spell out the word in your head. I'm like, why would that help? I can't see the word. She's like, why don't you see the word? I'm like,
I'm a terrible speller too, which is why it pisses me off that they're like integrating all these new like machine learning and AIs into spell check, and it's made it worse. Cause I'm like, I need you. Like, but
every time I second guess myself when my browser underlines something, I'm like, I'm pretty sure that's the right spelling. And I have to go look it up in search and it's the right spelling. Then I got to go add it to my browser library.
Yes, me too.
Thank you everyone for listening. Oh, I forgot. This episode's going out, I believe, I think it's in September. I'm going to be in London at a conference, SRE Day in London. I am speaking at the conference. I'm also hosting a conference called TalosCon for work. I try not to mix this podcast and my work, but I love to meet people that listen to the podcast in person. So if anyone is in London listening to this podcast and wants to come to TalosCon, is a free one-day conference for my work that is all about Kubernetes and Talos as an operating system, which is what we do. And then SRE Day is just generally about SRE type topics, which I'm fascinated on in general because I was also historically an SRE. So check them out. I'll put those links in the show notes so anyone could sign up and come if you're in London or around in a travel area of London. I'd love to meet you in person. So please reach out and we will talk to you all soon.
Take me to London in your suitcase.
I have so much computers I'm bringing. You won't fit. Look at my CD stack. I'm burning CDs for the conference. This is all our the swag.
Who even does that?
I know, right?
I love it. Just who does that? It's great.
Thanks for listening to Ship It with Justin Garrison and Autumn Nash. Subscribe now if you haven't already. Head to shipit.show for all the ways, or just search for Ship It wherever you get your podcasts. You'll find us. Thanks once again to our partners at Fly.io, to the mysterious Breakmaster Cylinder for these dope beats, and to Sentry. Use code CHANGELOG when you sign up and save $100 off their team plan. That's all for now, but come back next week when we continue discussing everything that happens after Git Push.